Chapter 11. Chemical Effects of Electric Current. Introduction. Your elders may have advised you to avoid using moist hands when handling electrical equipment. However, are you aware of the risks associated with touching an electrical item with moist hands? We already know that good conductors of electricity are substances that permit the flow of electric current. On the other hand, substances that forbid they are not good conductors of electricity, allowing little or no current to flow through them. In Class 7, we created a device to determine if a certain substance permits the passage of an electric current or not. Do you remember how the tester assisted us in making that decision? We discovered that whereas materials like rubber, plastic, and wood do not conduct electricity, metals like copper and aluminium do. But up until now, we have only utilized our tester to test solid-state materials. What about liquids, though? Does liquid conduct electricity as well? Let's investigate. Electrical conductivity of liquid. As our well knowledge, the ability of a substance to carry electrical current is determined by its electrical conductivity. You learned in your previous session that metals carry electricity. Let's do an experiment to determine whether or not all liquids conduct electricity. Do you know that liquid can conduct electricity under specific conditions, but the light may not turn on? This occurs because liquids do not conduct electricity as well as metals do. As a result, even though the liquid conducts electricity in some circumstances, the tester's light bulb may not light up. It's because there isn't enough current flowing through the circuit to sufficiently heat the bulb's filament, which prevents the bulb from glowing. Therefore, we utilize lead rather than a lamp to measure the conductivities of liquids. LEDs also require extremely little current to illuminate. Therefore, we utilize LED rather than a lamp to measure the conductivities of liquids. LEDs also require extremely little current to illuminate. An electrolyte is a liquid that conducts electricity and undergoes oxidation. Chemical effects of current. The term chemical effect of electric current refers to the chemical changes that happen in a solution when an electric current passes through it. The electric current causes a solution to split into negative and positive ions as it passes through. An atom or molecule becomes an ion when it acquires or loses one or more electrons. Positively charged ions, which lose electrons, are known as cations, whereas negatively charged ions, which gain electrons, are known as anions. The two phenomena that depend on the chemical reactions caused by electric current are electrolysis and electroplating. Electrolysis. As you are aware, solutions of acids, bases, and salts make up the majority of liquids that conduct electricity. An electrolyte is a solution that conducts electricity. Electrolysis is the process by which molecules of a solution split into positive and negative ions when an electric current is passed through them. An instrument known as a voltmeter or electrolytic cell is used to conduct the electrolysis process. It has two metal rods known as electrodes and a glass container filled with an electrolytic solution. a battery is linked to the electrodes. Anode and cathode are the terms used to describe the electrodes attached to the positive and negative terminals of a battery, respectively. Uses of electrolysis. Electrolysis has a large number of applications. It is used extensively for commercial purposes. The most common applications are as follows. 1. Electrophining. 2. Extraction of metals from its ore. 3. Electroplating. Electrorefining. The process of purifying metals by electrolysis is known as electrorefining. The metals are not pure or in an impure form when they are taken from their ore. The impure metal is turned into an anode, while a strip of pure metal is made into a cathode to purify the metals. This is accomplished by using a soluble salt of a pure metal as the electrolyte. The impure metal at the anode dissolves into the electrolytic solution when an electric current is passed through it, whereas the pure metal deposits on the cathode. This technique is used to purify copper, silver, gold, zinc, and other materials. Extraction of metals from its source. Electrolysis is a technique used to remove certain metals from their ores. An electric current can be used to produce aluminum, for instance, by fusing cryolite, Na3AlF6, and bauxite, Al2O3, to H2O. Electrolysis is also used to remove some active metals including sodium, magnesium, and calcium from their ores. By sending electric current through their molten states, electrolysis isolates metals like potassium and sodium. Electroplating. Electroplating is the electrolysis-based method of depositing a thin layer of a desired metal on a substrate. For instance, to increase their appeal, items made of inexpensive metals or other materials are coated with valuable metals like silver and gold. The object to be electroplated serves as the cathode in the process, while the metal to be deposited on the object serves as the anode. The electrolytic cell's electrolyte is chosen to be a soluble salt of the metal that will be deposited. The object, cathode, is covered with the desired metal, anode, when the electric current is passed through it. Zinc is used to coat iron objects, for instance, to stop rusting. Let's understand this process by the following activity. Uses of electroplating. Here are a few significant uses for electroplating. To either protect the metals or improve their aesthetics, thin layers of various metals are applied to metal objects. For instance, chromium is used to coat items like kitchen gas burners, bathroom faucets, and bicycle handlebars because it resists corrosion well. It looks shiny and is resistant to scratches. Jewelry is created by electroplating inexpensive metals with silver and gold. Tin is electroplated onto iron to create food storage tin cans. Due of iron's reaction with food, this prevents food spoilage. Zinc is electroplated onto iron to shield it from corrosion and stop rust from forming. In a nutshell, conductors allow electric current to pass through them. Poor conductors allow conduction only under special conditions. Insulators do not allow current to pass through them. Most liquids that conduct electricity are solutions of acids, bases or salts. Liquids allow the passage of current by the movement of ions present in them. Passage of current through solutions causes some chemical reaction to occur in the solution. Electrolysis is the process of breaking down of an electrolyte into simple substances by the electric current. Electroplating is casting a layer of one metal on another by the process of electrolysis.